Okay, in this lesson, we are going to learn about efficiency. You may have encountered some energy saving light bulbs that state that it has actually a power rating of 26 watt, but and is be as bright as other light bulbs that is 100 watt. So you look at this, there are different light bulbs. So you find that this is 100 watt, this is 26 watt. But in terms of lighting, this indicates the lighting. This 1007 is as bright as something that is 100 watt. It is energy savings because it uses less energy but yet can give equal brightness. But how is it possible? Or is it a marketing gimmick to trick consumer into buying something that's more expensive because this costs 60 cents and this costs $3? And that's where the concept of efficiency comes in. When we encounter the term efficiency, we may see similar terms such as power efficiency, energy efficiency, or work efficiency. They basically share the same concept. Efficiency is actually comparing output against input. Thus, power efficiency is comparing output power against input power, just as energy efficiency is comparing output energy against input energy. Efficiency is simply just a ratio of output versus input, and is usually expressed in terms of percentage. By principle of conservation energy, we always emphasize that energy cannot be created or destroyed. So starting energy is equals to ending energy, which means that based on this idea, shouldn't efficiency be just always 100% since the energy starting input is equals to your output? But we have to also take note that starting energy and equals to ending energy, the form of ending energy can be different from starting energy. So using a simulated light bulb as an example, you look at this light bulb, okay, focus on light bulb, you're taking electrical energy, this blue color, and you find that some of the energy become light, some of the energy become thermal, okay, as indicated by this orange. So light bulbs actually convert electrical energy into light and thermal energy. But for a light bulb, what actually matters most is actually the amount of light energy and not the thermal energy. So you can consider that the thermal energy is actually wasted and is not useful. And efficient light bulb doesn't consider the wasted thermal energy as part of its output. So generally, efficiency is actually equals to the useful output versus the input multiplied by 100%. If a light bulb converts 200 joules of electrical energy into 140 joules of thermal and 60 joules of light, the efficiency of light bulb is simply equals to 60 divided by 200 because the input is 200, the output is 60 of light, and the efficiency is just 30%. However, if it's a heater that actually does the same thing, convert 200 joules of electrical energy into 140 joules of thermal and 60 joules of light, the efficiency of a heater is actually 140 divided by 200, and it is 70%. So it is really dependent on what is considered to be useful. So coming back to the energy saving light bulb, if let's say the efficiency of a 100 watt standard light bulb is just 20%, okay, you substitute in, and the input power is actually 100 watts. So you find that the light output is simply just 20 watts because it's 20%. But if the efficiency of this 26 watt energy saving light bulb is actually 85%, which is much higher if you do a comparison, then if we do the same calculation of 2680 and this is 80, 26 watts, you find that the light output power is actually 20.8. So even though the energy taken in is only 26 watt, but is able to output the light equally as bright as the 100 watt light bulb. So that is why it is possible to get the same brightness or actually even brighter for a lower amount of power input. So the efficiency of the system is important, as low efficiency system means that a lot of energy is not productive or being wasted. And we usually can improve the system by increasing the efficiency, as it means that with the same input energy, we will be able to get more output energy. For the same output energy, we use lesser input energy. However, the maximum efficiency of any system is actually 100%. Okay, why is that so? It's because simply the output energy cannot be more than the input energy. So output is always less than or equals to input, and that's the best you can do. And it's why is that so? Is because principle of conservation energy, because energy cannot be created, so your output cannot be more than your input. Electrical motor rated at 80 watts is used to lift a load of 5 kg vertically up slowly. It's known that the efficiency of motor is 60%, and find the increase in height of the load after 15 seconds. Rated at power 80 watt means that the input power to the motor is actually 80 watts. The efficiency is 60, so we substitute in accordingly 60 and 80, and the output power is just only 48. Okay, because 60% of 80 is 48. So taking this, the total work done in 15 seconds is actually equals to the output power times time, because we remember power is equals to work done divided by time. So work done is actually power times time. So output power is 48 multiplied by the time, which is 15 seconds. So the total energy output is 720, and this energy output is used to increase the gravitational potential energy. So you substitute in the gravitational potential mgh, and accordingly it's 5 kg. So in this case, the increase in height is 14.4 meters. So that will be the end of this lesson. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysics.wordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.